Making markets. Changes is a trading parameter. Then we need to connect all this knowledge to trading markets. First, some jargon. When you want to affect a trade, you need to specify the thing you want to trade. The thing you want to trade, direction, whether you want to buy it or sell it, price at which you're willing to transact, quantity, how many shares, contacts, and also the quote size. If you want to buy something like a stock or a contract, you can say or otherwise indicate a bid to buy. If you want to sell, it's an offer to sell. Bid, offer. So if you want to try to buy 10 widgets for a price of $2 each, say 2 bid for 10. Why the fuck would it call it like? Okay. I guess direction, price, quantity. Okay. If you want to try to sell 10 widgets, then that would be $10 offer price for 10 offer for. I have 10 at 4. Oh. Like, what the fuck is this even? Wait, are chains root not quants? Are they individuals? I want to try to sell 10 widgets for a price of $4 each. Say I have 10 at 4. Now, if you're happy to do both the bow, you can. So 2 at 4, 10 up. When is this document from? Okay, I think they just set out the lingo. Okay. guess if 2 or less, buy, 4 or more, sell. Two or less, buy, 4 or more, sell, 10. That was cool, actually. That makes sense as well. Holy shit. So basically, what? That's cool. You basically take half of the amount and times it by n plus 1. That's cool. Okay. So we will call this this will return the expected value given the same odds for all, so like a die. So now the expected value for a 20-sided die, put 10.5. I guess I would have a market 10 at 11 X up, I guess. Let's work through this later, I guess. Adverse, can I mark them? Adverse selection. When you're trading against a human, someone who's presumably at least as good as thinking about market as you. This is like a very good thing to keep in mind when trading markets. When you're winning, someone is losing, and people don't want to lose, so they probably change their strategy. Or, even better, if you're winning, someone's losing, if you understand why someone is losing, and they're losing on purpose for some other reason, that's a good trade. Because then you know they're like, they want to lose to save themselves for something else. So the strategy might survive for longer. By security, that means someone else thought it was a good idea to sell it, which you should understand to make you wary. It helps understand why you're doing the trade. Are they just like you're trying to make a good expected value decision? That is scary. There's a good chance that you did the calculations wrong and misunderstood the contract terms or something. Do they care about the price? Sometimes people want to invest long term, or your interviewer commits to doing a trade to make your scenario more interesting, and they tend to care less about the exact price at which they're doing a trade. Yes, okay, so people really want to do the trade, and they want to do the trade more than their loss of doing a bad trade, basically. That's probably most people for most stocks. Adverse selection is the idea that the trades you get to do. Let's just anything new. Okay. Adverse selection is the idea that the trades you get to do are worse than they would appear, because someone else is selecting into the trade against you. In general, you should be more careful in cases where the calculations are complicated or the answer is hard to determine. You'd probably be sad to do a trade with your meteorologist about the weather in a week than something where you're more certain of the value. You're probably fine buying a D6. Okay. The idea of conditional probability is relevant there. When you make a market and someone trades against you, that should prompt you to update your beliefs. If you bought the correct value of the security, it's probably a bit less than initially believed. When making markets, it also helps to think conditional on my order being filled. What do I think the expected value of a security is? Given this updated expected value, would I be happy to have done the trade? So basically, if a lot of people like a contract, it's probably a bad contract. Is that the idea? Expected value is the expected value given it's filled. I'm not getting it. Jesus Christ, dude. What the fuck? have to draw once. As expected flips. Okay, I get it. Okay. You have to draw it once, so that's given. Then you have half a chance of being done and half a chance of having the expected throws again. So then you take the minus on both sides, basically. So you have 1/2 flips is equal to 1. So that means each expected flips will be 2 times 1. Just 2, okay. Damn, okay. Where's my notebook? Where's my pen? Oh, I found it. Okay, let's see. How many flips do you need? Okay, expected flips. How many flips do you need to see 3 heads in a row? You could either write one big recursive equation or figure out how many flips for 2 heads first and use that. Oh, that's smart. Say this is 2 though, then that seemed like a good way of doing it. Okay, so we have to draw 2. So this is 2 plus 1/2 E2 flips plus 1/2 0. And then this is another half E2 flips. That means we have so good way of doing this. E2 flips minus 2E2 flips is equal to 2. This gives us E2 flips will be I think it shouldn't be negative. Okay, let's move the negative over. Why is it negative? Did I misdo something? So we have minus flips is equal to 2. Okay, basically, E flips for 2 is negative 2. I think I did something incorrectly. Okay, I guess we write out the whole thing, maybe. E flips is equal to 1 plus 1/2 E flips I'm just about to write the whole same thing again. Okay, I guess I'm misunderstanding the whole thing then. expected flips. Okay, expected flips will reset every time. I'm so tired in my head. It sucks. I need to start sleeping more. Okay. Flip. You have to throw 2 times. There's a 50% chance. Is it in a row? In a row? Okay, that changes it a bit. Okay. Let's think about 2 first. You have to draw 2. There's a 3 in 4 chance. You don't get it, and there's a 1 in 4 chance you do get it. This is 1 in 4 E. There we go, I think. Flips. That would give -1/4 for 3/4. So this is E. Flips will be 2 times 4 divided by 3. 8/3. Okay. So now E flips for 3 would be 3 plus 4 times 2 is 1/8. E flips, which would give us E flips equal to 3 times 8, 24/7, which will be 3. No, nothing. Let's double check this math. This will be 7/8. 8 times 3 divided by 7. 8 times 3 is 24. 7, 21. I guess this doesn't equal anything. Okay. So this is like about 3.1, I guess. So this is almost 3. 2.9, about. Cool. I think that's correct. 2 to the n. 2 to the 3. Oh, that's not 1/4. That's like 1/27th or something. No? 2 to the 8, yeah. I guess you have to +3 every time you get here. Oh, that's a good point. No, wait, this is wrong, no? You don't actually restart from 0 every time you fail. You suppose you have your first flips were heads, heads, tails, so you don't get 3 heads in a row, but you still have a streak of 2 heads to your credit. You're not back to the very start. Some other failures. Well, this time I believe you are wrong. Head, heads, tails would start you from the beginning. Maybe. Okay, I get it. Okay. are we saying here that tails breaks, but if you get tails head, so that'll like reflip it? Maybe. Wait, what? That's such a backhand. What? Like, what the fuck? We're not gonna judge you for not being able to mentally multiply double-digit numbers in 5 seconds. Can people do this? Like, give example of. This is a 2 by 2, like 2 times, like 2 numbers times 2 numbers, right? Yeah. Fuck. Okay. I guess 4 times 6. Okay. Okay, 47 times 6. I can't even do that. Oh. Okay. 47 times 6. Jesus fucking Christ. 35 plus 2, 40 to 75 2,750. That was wrong. What did I do wrong? 6 times 7, 35. Six times 4, 12, 24. Didn't I say that? 35 plus 240. 4 plus 3. Am I retarded? Hello? Can you not do 6 by this times 10? Yes, you can. Is this just wrong? $240, 50, 60, 75, 275 times 10, 2,750. Okay, oh no, 7 times 5. It's 7 times 6. Okay. Okay, that would fail me the intro. Oh no. I'm fucking cooked. Okay. We're go again. For 8 plus 128 plus 16,100 and wait, fuck. 128 plus 16, 130, 44. Oh, fucking kidding me? Four times 2, 8. Plus 4 times 3, 12. 128. Times 10. 1,280. Plus 16. Oh, I just did 8 by 2. Fuck, okay, we go again. Also, here it looked like taking negatives better. I guess here would be 80 times 67 minus 67. Yeah. So this would be 670 times 8. Okay, so this is 56 plus 420 476 times 10, 4,000. Did I say 7? 4,760 minus 67, 4,760, 4,600 and something. Oh no. Okay, I'm done. This fucking sucks. You have to be really good at complicated math, although many of our questions are easier if you know a lot of math principles. We try to ask creative problems that you can reason through. In fact, I often prefer the simple intuitive answer one that involves a bunch of esoteric terms. You'll fail into if you get the wrong answer. This was a very good document though. Alright, okay, do we... I think we'll do these ones first. So this will be 75 minutes. We'll do one before dinner, one after, I guess. How should we do this? This timer. Oh. Can I go like multiple windows? Fuck. I guess we'll do one at a time. So this will be 15, 30, 30, yeah. Fuck. Okay, I'm just pissed. Okay. No calculator, only a page of paper and a pen. Part 1. Right. Good luck to me. I'm gonna quickly describe the problem and calculate it loud. 14, 22, 40, 9, 50, 1, 8, 12, 28, 29, 4, 10, 4, 4, 3. 2. Approximate square root of 18,000. So 4 by 4, 5 by 5. So somewhere probably at 4.5. Go to 18. This is close to 19. So this is like times 1,000, like 4,500 maybe. I guess I'll come back to this. For 8% of 2, so this is 2.35 times 48, 2.35 times 48, 40. Okay, double check this first. 1% is 2.35. 48, yeah, okay, yeah. 24, 28, 28, 16, 18, 20, 12, 14, 8, 9, 8, 12, 10. 1, so this is 112.8. 4. What's the closest? 9. Give us a reduced fraction. Oh shit. Is it the best to just multiply out, maybe? I think that would be the fastest to try to find the common denominator. So this is 19 plus 17 over, let's see here, 19 times 17, 7, 63, 7 plus 6, 13, 9, 1, 3, 2, 3. So this is 3, 2, 3. This will be 29, 36, 36 divided by 3, 2, 3. Huh. Maybe we can look for a common denominator instead. 19 times 2, like 40 times 3 could be something here. Or 5, 190, 7, 14, 21. Wait, the 7 multiplier only. If you go 10 will be 70. 140. Damn, I can't find a common denominator there. Okay. Can we get this? Ooh, no. Okay, we're 323 divided by 3. 23. I don't know. There might be a reduction there. We can come back to that, I guess. 5. Damn. Damn. Is there a quick way to do that? Okay. 2, 4, 8, 16, 32, 64, 128, 64, 128, 256, 4, 5, 12, 1024, 7, 8, 9, 10. I should subtract 2, 4, 8, 16, 32, 64. Oh, yeah, okay. 2, 0, 48, 4, 0, 80, 96, 11, 12, 8, 1, 8, 9, 2. Right, 8, 180, 192, yeah. I feel like I'm taking way too long here. 9, 9, 9 times 9, 9, 9. Damn, this is fucking sick. 81. 81 plus 8, 89. 81 plus 8, 89. 81, 9, 9, 8, 1, 9, 9, 8, 1, 0, 1, 10 plus 10 plus 10, 20. 10 plus, this is 10, 28, 10, 19, 9. ln e to the 5. So ln of e to the 5 will be 5. What the fuck are you doing? Oh, you're just delayed, I guess. Oh, that's the formula. Ooh, okay. I will look at that after. The next prime after 97. I think 103 is a prime. Is 101 maybe a prime? 99, could that be no? 98, no. Let us guess 101 maybe. Let's see, 33 times, no. 10 times 10, it has to be 101. 3 times 2. Let's see, what other primes do we have here? It's probably something times 3. What would be times 3? 9, 7 times 3. 21 times 3, so this is... yeah, I think it's just 101. Not sure about that though. 7 factorial divided by 4 factorial times 3 factorial. So this will be like 4 times 3 times 2 times 1. Then you can factor out, I guess, the 3 times 2 times 1. Wait. I guess it's just 4 times 2 times the factorial. Can you add them? Maybe this is just 1. 4 times 3 times 2 times 1 times 3 times 2 times 1. This is 4 times 2, which is 8 times 3 factorial. So we sort of have 7 times, okay, let's see here. 7 times 6 times 5 times 4 divided by 8. Let's see here, 4 times 5 is 20 divided by 8 is nothing helpful. Let's see here. Can get 35, 20 times I'm using too long. 35. Okay, 35 times 4. 71. 40. That's 5 times 8 times 3. No, 8. No, it's not. It's not even close. What the fuck? Do I just multiply this out? That might be quicker. 7 times 4. 28. 28. No. Times 5. I'm gonna skip this here. Come back to it. What's the remainder when it's divided by 29? Okay, what's the closest? How the fuck are we supposed to do this? How long do I have left? 1 minute? Oh no. What's x plus y and x minus y? What's x plus times y? So x is 13 minus y. So 13 minus y minus y. 5 minus 13 is minus 8. Divided by 2 minus 4, so y is 4. So x is y is equal to 4, x is equal to 9. That gives 28. No, 36. Is there a simple one? No, my god, what the fuck is that? 0, maybe? I think it's time's over. 32 seconds. Pi, so 3.14 to the 3, that's like 9, 12 maybe. 4 to the x, what's x? You take log to the 10. Fuck, this is stressful. I have no freaking clue. Yeah. It's 18. Really? I got the same values. I think I was correct. Yeah, okay. I think it's time over. Yeah. Okay. Do we go straight to part 2 or? I guess we check the answers first. Okay. Three, 4, 404, correct. 112.8. Oh wait, no. 137. I got 450. What was the question? Oh, of course. Okay. I wonder if there's a good way to solve that. I got 4,500. What did I think? Okay, small mishap there. I guess we write down how to approx square roots. 2. Oh, okay, 3. 120. Yes, that's correct. Oh, it wasn't simplifyable. Okay, that's correct as well. That's cool. 8192. 8192, that was correct as well. Holy shit, good fuck. Good fucking shit. 998. Oh, point. Okay. Since I got 998001, so this comma is like the number comma. Okay, nice. So that's correct. 7 is 5. That's correct. 8 is 101. That's correct. 9 is 35. That I didn't do. I guess we can see if my method was correct though. So this would be 7 times 6 times 5 times 4 divided by 8. 105. Okay, that wasn't correct. $35. I guess 19. I got 36. Oh wait, I didn't answer that one. No, 10, 36. I guess I just mistyped. So 36. Okay, that's correct. 12. 0, 14, 12. Oh, I forgot the versions. Nonagon. Nonagon is a 9-sided polygon. Okay, how the fuck would I have known that? Pi to the pi. That's 14. $22.6. I got really 26. Huh? I guess they mistyped. Alright, I'm gonna take a piss and then we start the second picture. Right, okay. Ready, set. Go. Section 2. Choose the best answer for each question. Two fair 6-sided dice are rolled. What is the probability of their sum is equal to 9? 2 6-sided dice. So 9 is 4 divided by 36. So this is 1/9 C. This 1/9. A standard deck of 52 playing cards are shuffled. What's the probability that the top card is a heart or a king? That the top card is a heart or a king, so that's 8 divided by 52. 52 divided by 2. I guess divided by 4. 52 divided by 8, does that work? Yeah, so 8 times 4. Fifty-two divided by 4 is 13. 8 divided by 4 is 2. Wait, what? What? The probability is 8 divided by 52. 52 divided by 4 is 13. That's 13. That's not an answer. None of these are correct, I think. Maybe we should. I guess I'll come back to that. Flip a fair coin until you see 2 consecutive heads. What's the expected number of flips? I think this is 2. Are all of these wrong? You flip a fair coin until you see 2 consecutive heads. What's the expected number of flips? Okay, so the expected number of flips is... Oh, it's... Okay, I was wrong. Oh, damn, this was the difficult one. Damn, okay. Fuck. So for 1, it would be 2. I guess a good. And for 3, it would be like 13, I think. So that makes me guess like 6 here. Do I remember the way to do it though? I'm gonna guess 6 here. So this is B. But we need to do some questions with to practice those. Box contains 4 red, 3 blue, 3 green balls. 2 balls are drawn without replacement. What's the probability that they have the same color? Okay, so probability. They have the same color. How the fuck are you supposed to do this? Oh no, I'm actually cooked. Aren't this very difficult? Since it's not asking about a specific color. It's asking, you draw one, you get the color, and then it like updates it. Okay, so, okay, it is multiple choice, so we can abuse that a bit. If it was blue, the first color, so this will probability blue given blue. So that would be 3 over what's this? 12? No, 10 times 2 over 9. So this would be 6 over 90. Divide that by 6, right? So that would be wait, no. If we divide it by 6, 90 by 6, we get 15, so this would be 1 over 15. If we say it's the same would be for green. If we say instead pick red, this would be 4 over 10 times 3 over 9, which would be 12 over 90. So this would be twice as likely. So this would be 2 over 15, which would mean, I think we can actually just do 2 over 15 plus 2 over 15. So we basically have 4 over 15. Would be a good guess. Which none of these are. It's close to this. Basically, my idea is to say it. Wait, no. This is wrong. It's between 1 divided by 15 and 2 divided by 15, basically. So it's like 1.5 divided by 15. If you divide 15 by 10, we have 1.5. So this is 3 over... No. How can we solve this easily? $15 times 2, so no. 3 by 10, no. 15 times 2 times 3 is 90. I hate all of these guesses. I think this is actually wrong. This will be probability of picking B divided by so this would actually be probability of B given B divided by the probability of B. So this would be This is just recursive. I don't know. I don't actually know. Bro, I can't do any of these. A continuous uniform random variable x is between 0 and 2. What's the probability that x is between... I guess you just divide by range, right? 5, 6, 7. So that's like 0.7 divided by the range 2. So this is 0.35. B. You roll a fair die repeatedly. What's the probability that you see a 6 before you see a 1? It has to be 1/2, no? It has to be. I'm just going to pick 1/2. That's A. To save time. Random variable y takes value 0 to 1, 2, and probabilities respectively what? A random variable y takes values with probabilities. What is var? Okay, if we get 0, we have a 0.2% chance of getting 0. What does var mean? I don't know what var means. I guess he's actually asking what is the expected value here. So this is 0 times 0.2 plus 1/2 plus 2 divided by 2 times. Okay, so this is 0.5 plus 2 times 0.3. 3 times 2, 6. So this is 0.5 plus 0.6. 1.1. Okay, I don't know then. In that, I don't know what Poisson process is. We're at lambda 3 events per hour. What's the probability of exactly 5 events in 2 hours? There's some factor for some. I guess I can ask. Okay. Sorry, what? Would lambda not be? Well, that's per hour, I guess. 3 times per hour, so I guess per hour. Exactly 5 events in 2 hours. So this is 5. Okay. So I guess that would actually be in 1 hour 2.5. I I guess from that we calculate 2 and 3 and take the middle, maybe, I don't know. Damn, okay. So per I don't know. Which of the following points, a pair of random variables are necessarily independent? I guess this means where x is between 0 and 1, but x depends. This is dependent. I guess necessarily here means that they have to be completely independent. Number of heads in the first 5 flips and total heads in the first 10 flips of the same coin. That doesn't seem like it. Outcomes of 2 distinct fair dice. Feels like a simple mean of us. I guess C. Three fair coins are flipped, conditional on the first coin showing heads. What's the probability that exactly 2 heads appear in total? 3 fair coins are flipped. Bro, I'm kind of stressed. Okay, so probability of 2 head given head. This would be probability of head given 2 head. No, this is the probability of head and 2 heads divided by the probability of head, I think. So this will be 2 times the probability of head and 2 head. So that's just 1 over 4. 2 times 1 over 4. So this is 1/2, I think. I guess we can try 2. Oh, it's a heart or a king. I thought this was an ace. I misread that completely. Okay. A heart or a king. So that's 13 plus 3. So that's 16 over 52. If we divide that by 4, we get 4 over 13. Which is B. Okay. Cool. If you flip a fair coin until you see 2 consecutive heads, what's the expected number of flips? Do I think I will be able to do this? This is probably one of those things you have to get good at, though. How much time do we have? basically you have a state called tail head, which has a probability. Okay, so basically, okay. So this will be the probability of head will be the probability of tail head times the probability of head plus the probability of tail times the probability of head, which is back to where we started. Plus the probability of head times 0, I think. So probability of tail head. So this is 1/4 times 1/2, so this is 1/8. Probability of tail 1/2 times probability of head. Head is 1/4 times 1/2, so this is also 1/8. So I get 1/4. Is okay. Probability, of course, probability of head is 1/4. Fucking piece of shit. Okay. So this is okay. I did this incorrectly. Let's cancel this. This would be expected head will be the probability. No, expected tail head times the probability of tail head. Or no. No, this would just be the probability of head, I think. Since we need a head, okay. Plus expected tail times probability of head. I think this is it. And do we have +2 as well? Maybe? Could be +2. Could very well be +2. Let's see what this is first though. Okay. So expected number of throws to get tail heads. How the fuck do I know that? Wouldn't that be the same thing? Okay, the second one, expected number of throws to get tail is 2 times probability of heads. Okay, this is 2 times 1/4, which is 1/2 or 1/2. It just feels a lot like the expected amount of throws for tail heads would be the same as expected amount of throws for heads. Wait. No. This is expected number of throws for heads times probability of a new head, I think. So this would then be 2 times 1/2, so this is 1. 1 plus 1/2. Is that even? Okay, so I think this might be also +2. Which means we have 2, 3, 7, over 2. Oh, piece of shit. I don't know. I'm still answering C, I think. I think I'm gonna just say finished here. Okay. We have D, that's wrong. 2B, that's wrong. 3A, that's wrong. 4, I didn't answer. 5B, that's correct. 6A, that's wrong. 7, I didn't answer. Let's see. B 8 would be A, I didn't answer that. 9 is C, so fucking hell. And 10 is B. So fuck, I got all wrong almost. What? Two fair 6-sided dice are rolled. What's the probability that their sum is 9? Four divided by 36. That's 1. 36 divided by 4 is 9. This has to be it. I guess ChatGPT just didn't. It has to be 1 over 9. Yes, okay, so this was correct. This answer sheet is wrong. Okay, 2. This will be B. Yes, so that was correct. Now 3. This one is a bit more tricky, or a lot more tricky actually. I got it correct though.
Welcome back.
Welcome, guys. So today I want to solve this.
That has been a joke, no? Okay, so I didn't have the correct answer there. 4 over 15, what did we say? We said somewhere in between. No, we said 4 over 15, but then I thought it was incorrect. Okay, so that was the way to do it, okay. Basically, you take the probability of picking a blue ball and then a blue ball, or a green ball, so this would be the case 2 out of 15 times, or the red ball, which would be 2 out of 15. So this would be 4. Okay, so that was how to do it, okay. 5, 0.35, that was correct. You have a 50% chance of seeing 6. That was also correct. Okay, so most of these are actually correct. It's just the answer sheet was wrong. Okay. I guess we'll just continue. Okay, what is this? So probability of y equal to 0, 0. Okay. Okay, so it was asking expected value, basically. What did I say on this one? 7. I gave up. Okay. This is the variance. Because I did this thing. Okay, so it's... Is there some logic behind this? I don't see it. This is just a formula, if you know the formula checker. Okay. C and D. Ah, I did that correctly. Holy shit. Is this the same formula? Okay, I'm gonna stick to my formula, I think. Okay, so probability 2 heads given head, that's the probability of head and 2 heads, which is just 1 over 4, because that's the same as probability of 2 heads. And divided by probability of head, which is 1/2, so that's okay. I guess var is variance, which then would be calculated by how spread out around the variable x around its mean is. Expected value of x squared minus, okay. Right, last part. Section 3, provide full working and dice game, stop or roll. You may roll a fair 6-sided die up to twice. Okay, so the expected value of 1 is 3.5. So the expected value of 2 is that just 3.5 divided by 3.5 times plus 3.5. So that's still 3.5, I think. So if you get less than 3.5, you roll again. But this feels not like 3.5. Since you wouldn't roll again if you have greater than 3.5, but you would roll again if you have lower than 3.5. So basically we have, there's some other factor there. I guess you have 3.5 plus roll again, 3.5 plus not roll again, 0 divided by 2. So I think you actually have 3.5 plus half of 3.5 for this. Okay. So this will be 3.5 plus. So this is 3.5 times 2. 7 over 2 plus 3.5 over 2, which is 10.5 divided by 2, which is 5.25. Really? That high? There's no fucking way, right? I was sort of thinking like 4 or something. Okay, so we have 3.5 expected value, then you plus 3.5 expected value plus 0, since you would roll again, divided by 2. Okay, I'm just gonna assume this is correct then. Okay. I don't see why it's not. Okay, so we have expected value. What's your expected value of the optimal? Okay, so this is just final answer. Okay. 2. World Series problem. Team A and B play best of 7 series where each game is independently won by A with probability. Okay, so basically what's the probability that A wins? That A loses 4. What's the probability that A loses 3 times in a row? I think would be the same thing. Okay. So this is I think that's just 0.45 times to the third. Okay, I can't do that in my head. 25, 20, 2, 20, 16, 17, 18, 5, 2, 0, 2. So this is 0.2025 times 0.45, 25, 12, 1, 10, 20, 8, 10, 0, 1, 8, 5, 2, 1, 1, 9. 1, 2, 0. Basically, we have a probability of 9.1125% of going 7 games. Card game, expected value. A standard deck is shuffled. You reveal cards one by one until you see the first ace. You earn $1 every time card revealed. Oh, these are tricky. I guess we... Isn't this like an expected value inside an unexpected value? Can you go like just remove them? I guess we can, right? I don't have the brain capacity to understand why not, so let's try. Okay, excluding the loss, what's the expected value of the game? Okay, so we have a 4 in 52 chance, so that's a 1 in 13 chance of stopping the game. So the expected value will be 1 over 13 times 0 plus 12 over 13 times 1. That's not correct. No, okay. This is a 1 over 13 probability of getting 1 and then stopping, plus getting 1. Maybe times? much time do we have? 18. Like, still. The chance of stopping the game is 1 in 13. So basically, that's basically 1 in 13 you get. Okay. Let's say this is 1 in 13, you get 0, but you start with 1. So we will have, and then you have a 100% chance of gaining 1. Okay, I want to say 2. Since you start with 1. No, I think it's a team. I don't know how to do this at all. Okay, let's calculate the expected value of the losses then. Okay, maybe do them at the same time would be better. The expected value will be the chance of gaining 1. I think I'm gonna end it here. I'm 200 and I don't want to push it too much. Right, okay. I got 5.25. I got 9. Or just the problem was that you can't have a 3.5, so the expected value guess doesn't work. Okay, we sum the probabilities. The first is k times the probability that the second is k in 3 cases we have the probability of, or in 3 cases we have the expected value of 3.5 to roll again, and in these 3 cases we keep it, but the chances of getting to the, well, each of these cases is number 6. That sucks. All right.
So this is one of our first lectures on probability.
If you win 2 times as much as your bet and get your original bet back. But if you lose your entire bet. You're going to be tossing this coin 100 times. What is the optimal bet size at each flip to maximize long run expected winnings?
Okay, so just to clarify the question then, so I'm starting with $100. I can bet as much as of it as I want. And if I win this coin flip, I'll earn 2 times of my bet. And so I'll have $100 plus that 2 times of the bet. And otherwise, I'll just lose the amount I bet entirely. And I'm doing this 100 times.
Exactly. So in your first example, you'll have 300 because you'll have 200 plus 100. In the second example, you'll lose it all. The game is over and you walk away with nothing.
Okay, awesome. Let me think about that.
Might stream later.